Alright, this is Mr. Lehan Teaches You Stuff, Grade 9 Chemistry Lesson 9, Isotopes and Ions. Alright, so why don't we start off with isotopes. Now an isotope is an atom with the wrong number of neutrons. Now, I put wrong in quotation marks because there isn't really a right or a wrong here. It's just a helpful way to remember this. And here's what I mean. The atomic mass of an element is not always a whole number. So if you look on the periodic table, you'll notice that the atomic mass is often a decimal. And this is because it's an average of many isotopes of the element. So if we take a look over here at the box with chlorine in it, the atomic mass says 35.45. And the reason why is because chlorine can potentially have either 18, 19, or 20 neutrons. And this would mean it would have an atomic weight of either 35, 36, or 37. But you don't usually get a pure sample of just one isotope of chlorine. So when you take a sample of chlorine, and it's all pure chlorine atoms, you're going to have a mixture of all those isotopes. So if you actually weigh that sample, you figure out the mass of that sample, and then you divide it by the number of atoms that would be in that sample, you end up figuring out that that each one weighs, on average, 35.45 atomic units, or atomic mass units. So that's why there are decimal places in the atomic masses on the periodic table. It's because of isotopes. All right, next we'll move on to ions. And ions are atoms with the wrong number of electrons. Once again, there's no right or wrong here, but they are atoms with an unusual number of electrons, right? Not the normal amount that you would expect. So because they have either fewer or too many electrons, they will have a charge of some sort. Because remember, electrons are negatively charged. So if you take away a negative charge, they'll be positive, or if you add a negative charge, they'll be negative. So for example, oxygen ions have a charge of 2-, while lithium ions have a charge of 1+. Noble gases. Noble gases do not form ions. And the reason why is because noble gases have a full valence shell. So their outer shell, their outer orbit there, has as many electrons as it can fit. So they don't form ions. And the reason why elements form ions to have a full valence shell. That's the whole reason they do it. So noble gases are already done. They don't need to do anything. So elements will either gain or lose electrons to have a full valence shell, just like the noble gases. So if an element gains an electron, it becomes negatively charged, like chlorine. So here we have chlorine. To have a full valence shell, it needs to gain 1 electron. And now, because it has more electrons than protons, it's negatively charged. If an element loses an electron, it becomes positively charged, like potassium. So here's potassium, and it has that 1 extra electron there in its valence shell. If it gets rid of that, it'll be just like argon, the noble gas. So it gets rid of that, and now it has more protons than electrons, so it is positively charged. So can an element lose or gain a proton instead of an electron to become an ion? And the answer to that is no, most certainly not. If the number of protons changes, which it doesn't, the atom would be a new element. So for example, we have fluorine here. Fluorine has an atomic number, top left corner, of 9. If we added a proton to that, it becomes neon. It's a totally different element. Remember that elements are defined by the number of protons in their nucleus. So you can't really change that. It doesn't make them an ion if you change the number of protons. And really, you don't change the number of protons in an atom. Now, how do you know what charge an ion would be? Let's figure this out. So what charge does lithium form? So lithium here has 3 electrons, and it's got 1 in its valence shell. The closest noble gas to lithium is helium. So what do we need to do to make lithium look like helium? Well, we need to get rid of this one valence electron in its valence shell. If we do that, then it's just like the noble gas helium. It has a full valence shell. Because it's lost an electron, it becomes positively charged. So lithium forms an ion with a charge of 1+. Now what charge does a fluorine ion have? So fluorine has 7 electrons in its valence shell. So is it going to lose all 7 of those to be like helium? Or is it going to gain 1 to be like neon? Well, it's going to be a heck of a lot easier to gain 1 than it is going to be to lose 7. So fluorine gains 1 electron, and because it's got more electrons than protons now, it has a negative charge. So fluorine forms an ion of 1-. Now what charge does a nitrogen ion have? Well, nitrogen's got 5 in its valence shell. So the closest noble gas to nitrogen is neon. So it's going to be easier to gain 3 electrons than it will be to lose 5. So nitrogen gains 3 electrons and then gets a charge of 3-. So nitrogen forms an ion of 3-. Now you may remember from the last video that all the elements in a group will have the same number of valence electrons. And because of this, they're all going to form ions with the same charge. So here's the ion charges in the periodic table. The first column, first group, gets charges of 1+. The second column, 2+. Then we get 3+. And then right here, we don't really give them charges in this column. We've got carbon. It has 4 electrons in its valence shell. So if it needs 8 to be stable, it's either going to have to lose 4 or gain 4. So it's kind of in the middle, so it doesn't really form an ion easily. So we just don't give those charges. Now we're into the nonmetals, and these form negative charges. So now we have 3-, 2-, and 1-. And then last but not least, we have our noble gases, which do not form ions. So here we have the periodic table, and this one has all the ion charges on it. So in the top right corner, we have the ion charges for all these elements. And if you look closely, you'll see that some elements show multiple charges. So all these highlighted yellow ones, they have more than 1 ion charge. Now these are called multivalent elements, and some metals can form more than 1 stable ion. So if we look at the box for copper, for example, you'll see in the top right you have the ion charges that it can form. It can form either 2+ or 1+. So copper can have a charge of 1+ or 2+, which means it can either lose 1 electron or 2 electrons and become stable. If we look at iron, iron can form an ion of 3+ or 2+, which means iron can become stable by either losing 3 electrons or losing 2 electrons. So those are multivalent elements. Now it's important to notice that the first 20 elements all have only 1 stable ion. So chances are, if on a test you get an element that isn't one of the first 20, your teacher has put it there because it is a multivalent element. So that's a good thing to watch out for on tests. Polyatomic ions, another type of ion. Now sometimes a group of atoms can act like a single ion. So for example, carbonate. Carbonate is CO3 2-. Now what that means is that the whole CO3, that carbon and those 3 oxygen all mixed together, they all have a charge of 2-. So that whole thing has 1 charge of 2-, that whole group. So that means that carbonate acts similar to an oxygen ion or a sulfur ion, which are also 2-. And because this polyatomic ion is negatively charged, it will react with positively charged metal ions. And we'll get into that in the next video. But the important part to remember here is that the whole group of atoms behaves similar to just one single ion. So another group is a hydroxide group, which has a charge of -1, or 1 minus, I guess. A sulfate group, and a phosphate group. And if you look at the names here, except for the hydroxide, you'll notice that everything ends with -ate. That's a good thing to note. If you're ever looking at something and it says carbonate or sulfate or phosphate instead of phosphide, then you'll know that you're probably dealing with a polyatomic ion. Alright, so that's it for this video. Tune in to the next video, Ionic Compounds Part 1.